Objective 4. Construct histograms of continuous data. We are now ready to draw histograms of continuous data. For example, we're going to be drawing a histogram of continuous data. We're going to construct a frequency and relative frequency histogram of the 5-year rate of return data discussed in the previous example. And this is what we got from the previous example. Now, we had our classes, we have our tallies, which we don't need in this scenario now. We have our frequency and we have our relative frequency, and this is what we want. Now, to draw the frequency histogram, we're going to use the frequency distribution in the table. So first, we're going to label the lower class limits of each class on the horizontal axis. So down here, okay, we're going to label. So we're going to start with the lower class number 8. So you see there's a gap here between 0 and 8. Because we're starting with the lower class limits, we have 8, and then we're going to go, there's 9 in the middle, and then there's 10, and then there's 11, and then there's 12, all the way up to 20, since we go from 8 to 20, okay? And then for each class, we're going to draw a rectangle whose width is the class width, and whose height is the frequency. Now, for the relative frequency histogram, the height of the rectangles is the relative frequency. So let's go ahead and finish with this next part over here. So our vertical axis is going to say frequency, and we know that we're going to go all the way up until 13, since we're going to go from 0 all the way up to 13, so that would be 14. So the first thing we're going to do is we're going to go ahead and then create our histogram. So we know that for the class between 8 and 8.9, or it's the same thing as 9. So technically, it's close to 9, so it would be close to 9 here. We're going to have a bar graph that goes from here to here, since it represents 2. Okay? And then between 9 and 9.99, we also have 2. So that means from here to here, we also have 2. So we have 2 here, and then we have 2 here. Okay? And then between 10 and 12, we have 11. So between 10 and 10.99, we have 4. So we have this bar that's going to go all the way up to 4 for that class. Okay, and then between 11 and 11.99, or 11 to 12, we know that we're going to have 1. So we're going to go all the way up here and go halfway to represent 1. Okay. And then let's go ahead and put in the middle points here. So this is 13, and this is 15, and this is 17, and then this is 19. Okay, so between 12 and 12.99, we're going to go all the way up to 6. And then between 13 and 13.99, we have 13. So that means we're going to go all the way up to here. So there is 13. And then we have 14 to 14.99, which is 7. So we're going to come up here. There's 7. And between 15 and 15.99, it is 3. Okay, and then between 16 and 16.99, we have 1. And then between 17 and 17.99, we have 0. And then we also have 0 for here. And then between 19 and 19.99, we have 1. So therefore, there we have our frequency distribution there. Okay. And then likewise, we're going to do the same thing over here. So again, the horizontal axis is going to be the lower class limits of each class on the horizontal axis. So it's going to be very similar. It's going to go from 8 to 20. And remember that we have 9 here. We'll put 11, and then 13, 14, 15, 17, and then 19. And then if we round this to 2 decimal places, okay, this is going to be 0.03. This is 0.33. 0.18, 0.08, 0.03, and that's 0, 0, and then 0.03. Okay, so we have our rate of return here, and then over here is going to be our vertical, which is the relative frequency. So between 8 and not 8.9, we know that we're going to go all the way up to 0.05. And just let me put in 0.05 here. And then between 9 and 9.99, it's also 0.05. And then between 10 and 10.99, it's 0.10. So 0.10. Between 11 and 11.99, it is 0.03. 0.03. Between 12 and 12.99, it is 0.15. And between 13 and 13.99 is 0.33. Between 14 and 14.99 is 0.18. Between 15 and 15.99 is 0.08. Between 16 and 16.99, it's 0.03. And then between 17 and 17.99, we have 0. Same thing with 18 to 18.99. And then between 19.99 is 0.03. And so therefore, we have our relative frequency histogram. Now let's go ahead and graph these on Statcrunch. Okay, so if we want to construct this on Statcrunch, okay, let's go ahead and do this. Okay. So we're going to open up our data. So we already have our data typed in. So we have all our data in for the returns. Okay, and then what we're going to do is, it says here that we want to be able to, we already entered, we're going to select graph and then highlight histogram. So we're going to go ahead, we're going to come in here, we're going to select graph. Okay, we're going to select graph, and then we're going to select histogram. We're going to make sure that we select this column. We want our frequency. And then where are our bins going to start? Well, we started at 8. So we want to make sure that 8 is in there. And then our width is going to be 1. Okay. And then we'll keep our values on the above a bar so we can compare to that. And then that's it for that one. So we're going to go ahead and then select compute. So let's go ahead and drag this out just a little bit, and then we can see how similar it is to the one that we just did. So let's go ahead and copy this. Okay, so here we're going to copy it, and you can see as the one that we did by hand, it is very comparable here. Okay, now what we want to do is now we're going to go ahead and create the relative frequency. So all we need to do is come back in here where it says options, and then select edit. Okay, and then we're going to create the type now to be relative frequency. We already have our information in there for the bins and the width. And so now we know that we want to make sure that the value is going to be above the bar, which they are. Now we're going to select compute. And therefore now we have our relative frequency histogram. So let's go ahead and copy that and compare it to the one we did by hand. Okay, and so therefore, here is our graph, and you can see how it is comparable to the one that we have up here. Okay, now let's move on here. Now it says constructing histograms is somewhat of an art form. Okay, so what that means is that in both previous examples, the choices of the lower class limit of the first class and the class width were rather arbitrary. Although formulas and procedures exist for creating frequency distributions from raw data, they do not necessarily provide better summaries. There is no one correct frequency distribution for a particular set of data. However, some frequency distributions better illustrate patterns within the data than others. So constructing frequency distributions is somewhat of an art form. Use the distribution that seems to provide the best overall summary of the data. Now, next, you will use an applet to explore how changing the class width and the lower class limit of the first class affects the appearance of a histogram. As you use the applet, remember, the goal is to design a distribution that is best for revealing the patterns within the data. Okay, so let's go ahead and take a look at the applet. Okay, next what we're going to do is activity 1, choosing class width. We're going to use the applet to answer parts A through E. Now note that this applet uses density instead of frequency or relative frequency as the vertical scale. Now don't worry about the vertical scale, just concentrate on the shape of the graph. Okay, so if you take a look here, here is the applet. Okay, so if you look here, histogram with sliders for rate of return. So down here is the rate of return. Okay, and then our vertical is a density. So the first part is the starting point. Okay, so you can scroll here from left to right depending on the number that you want. And then down here represents the bandwidth. Okay, so for part A it says move the starting point to slider 8. So we're going to move all the way to where the number says 8. Okay, so there's the number 8, starting point is 8. And then the bin width in the applet, the bin width is equivalent to class width. So we're going to move the bin width slider to 2. So let's go down here to 2, okay? And it says write down the number of classes in the histogram. Well, how many classes do we have? Well, this is a bar, so that's 1, that's 2. Right, there's 1, 2, 3, 4, 5, and then 6. So therefore there are 6 classes. Okay? And if you notice here the first class, if you highlight it, it says rate of return is going from 8 to 10. And this one is going from 10 to 12. This one's going from 12 to 14. This one's going from 14 to 16. This one's going from 16 to 18. And this one is going from 18 to 20. Okay? Now let's take a look at the next question, part B. Okay, so in part B, okay, it's telling us to leave the starting point at 8, which it is. So the starting point is at 8. And then we're going to move the bin width to slider 4. So we're going to move over to the right, and then we're going to go to 4. So now the bin width is 4. Now it says write down the number of classes in this histogram. Well, we have one class that's going from 8 to 12, and then this class goes from 12 to 16, and then from this class is going from 16 to 20. So now we have 3. So now we have 3 because we changed the bin width. Okay, now let's go down to part C. Okay, so for part C, it's asking us to leave the starting point slider at 8, which we're going to leave at 8, and now we're going to move the bin width to slider 1. So we're going to go all the way down here to where the bin width is 1. Okay, now we're going to write down the number of classes in the histogram. Well, this class is going from 8 to 9. So you can see the bin width is 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we should have 2 in here. So 10, 11, and then this makes this 12. So we actually have 12 classes, and these ones here would be considered a 0 for the value above the bar because we don't have any there. Okay? Now let's move down to part D. Now part D is asking us to move the bin width slider to 5. So that means that we're going to leave it at 8, and now we're going to move it to the bin width to 5. So let's move it to 5. Okay, now notice 5 here. We have our bin width, so we still have 3. We have 3 classes now. Okay, and then now we're going to move the starting point slider between 2 and 4. So we're going to move down to here. Okay, so here is 2, right? So there we have 3 classes, and now we're going to move it to 4. So we're going to move it in between 4, and what's happening when it's in between 4? Okay, what happened now is it created 4 classes. And what's happening with the shape? Well, if we take a look at 2, right, we have sort of a nice looking shape here, okay, that kind of increases, goes all the way up, and then it comes back down. Okay, now if we move to 4, okay, it's very low on the left side, comes all the way up, and then it slowly decreases here. So you can see what the shape of the histogram changes as the starting point increases from 2 to 4. Okay, and now let's take a look at part E. Okay, so if we take a look at part E, okay, it's saying put the starting point now back at 8. So it's back at 8. And it says adjust the bin width slider between 0.4 and 5. So we're going to go all the way down here to where it says 0.4. Okay, and then which bin class width would you say is the best and why? So this is something that you're going to decide which one you think is best. So here's 0.4. Okay, there's 0.6, 0.8, 1, 1.2, 1.4, 1.6, there's 2, there's 2.2, 2.4, 2.6, then we get to 3, and then in between 3 to 4, and then let's take a look at what happens between 4 and then 5. Okay, so which bin class width would you say is the best? If you take a look here, right, this is starting to give us a little bit more of a picture of what's going on. And remember, variability is something that you want, right? How does the data vary? Or how is it spread out? These are some things that you want to ask yourself. Okay, now that we've done that, based on the applet activity, it says we can see that there is no right frequency distribution, but there are bad ones. The goal is constructing a frequency distribution is to reveal interesting features of the data. And with that said, we typically want the number of classes to be between 5 and 20. Now, when the data set is small, we usually want fewer classes. When the data set is large, we usually want more classes. The larger the class width, the fewer the classes in a frequency distribution. We're going to use the following guidelines to help determine an appropriate lower class limit of the first class and class width. So this is how you would approach figuring out how to make your classes. So, guidelines for determining the lower class limit of the first class and class width. Now, choosing the lower class limit of the first class. Now, choose the smallest observation in the data set for a convenient number slightly smaller than the smallest observation in the data set. So for example, in the table that we have below, okay, the smallest observation was 8.28, okay, and let's go ahead and highlight that from what we did previously. So here is the smallest observation, okay. Okay, and so a convenient lower class limit of the first class is going to be 8. Okay, so that is our value 8. Okay, now determining the class width, well, we're going to decide on the number of classes. Generally, there should be between 5 and 20 classes. The smaller the data set, the fewer the classes. So for example, we might think 10 classes would be a good choice for the data in the table below. Okay, so we'll write that below because that's what we're dealing with here. We're looking for the table below. Okay, now determine the class width by computing the following. So whenever you want to find the class width, you're going to take the largest data value, okay, and then you're going to subtract by the smallest data value. Okay, so we know what the smallest data value is. We're going to take the largest data value, and then we're going to divide it by the number of classes. Okay, so we're going to divide it by the number of classes. Okay, now let's take a look at this example that we've done. Okay, so we're going to round, once we do that, okay, we're going to round the value to a convenient number. So for example, using the data in the table, okay, that we have, okay, we're going to obtain, okay, we're going to obtain the following. Okay, we're going to take the largest data value, which is 19.43. That is the largest data value in a set. And then we're subtracting the smallest data value in a set. And then we're dividing it by the number of classes that we like. Okay, so if we take 19.43 minus 8.28 and divide it by 10, it's going to give us 1.115. Now we're going to round this down to 1 because this is an easy number to work with. So therefore, we're going to say that our class width is going to be 1, which is what we did. We end up getting 1 for the class width. Now, rounding up may result in fewer classes than were originally intended, while rounding down may result in more classes than originally intended. Okay, so that's how you find the class width if it's not given. Okay, now what happens to the number of classes as the bin width increases? Well, as the bin width increases, the number of classes decreases as the bin width increases. The number of classes in a frequency distribution is typically between what two numbers? Well, it's typically between 5 and 20. Okay, explain how to choose the lower class limit of the first class in a frequency distribution, where you're going to choose the smallest observation in a data set or a convenient number slightly smaller than the smallest observation in a data set. And then once you decide on the number of classes, explain how to determine the class width. Well, you find the difference between the largest and a data value and the smallest data value, and then divide that difference by the number of classes.